here we go. This one says, we're talking logarithmic expressions. Have you heard of logs before? Not like chunks of wood, but logarithms. You'll do more with this in advanced math. You'll deal a lot with logs in advanced math, and if you go to calculus, you'll do even more with logs, but this is just kind of where logs get introduced to you. You've probably never worked with them before, so this is probably very new. Maybe that's why I like it so much. It's a new thing. We like new things, right? Change is good. Yeah? Okay. So logs, the idea with logs is you're working with the inverse of an exponential function, okay? So we've been talking exponential functions, a times b to the x. What are you guys watching over there? You should put it away. There we go. A times b to the x, right? Y equals a times b to the x power. That's an exponential function. Today we're doing the inverse of that. Remember when we found an inverse, we swapped our x's and y's, and there was a function that reflected over the line y equals x, right? We did that in last chapter 6. Yeah, it's totally right. Yes, we did. That's where logs kind of relate, okay? The log is the inverse of an exponential function. So when we're finding the log of something, we're actually finding an exponent, which is why sometimes it feels a little backwards how we're doing things, but I'll show you what that looks like. So here's how it works. A log of base b, okay, so b being your base, your bottom number, if you will, of a positive number, has to be a positive number for x, is log base b of x will equal y. Now, that only works if b to the y power equals x, okay? So what you're going to get really used to, really comfortable with, is saying this to this power equals that. B to the y power equals x. B to the y power equals x. Okay, so that's the relationship. It kind of feels like this little backward circle, counterclockwise circle that you're going to be doing a bunch, okay? But just remember, a log is an exponent. We're looking for the exponent. So if you look at this situation, it says write the exponential equation in its log form. Well, if you look up here, we said this becomes this. Well, now they're giving you that, right? 5 to the second equals 25. So see if you can put those pieces in the right place here. This would be log base what? What would the b in this scenario be? The 5. Log base 5 of, so what is our x value? That's the 25. So log base 5 of 25 equals what? 2. We said a log is an exponent, right? So the log of this is our exponent, that 2, okay? So it feels a little funky, and it feels real funky at first, but you'll get really used to it because they all look the same. They're all that same setup. So if I say for that one, log base 5 of 25 equals 2, think about this one. What is it going to equal? What's my standalone in this setup? It's the exponent. It's the 6, okay? Then your base, right? Your base, your bottom, your drop down is your base in terms of what has the exponent with it. So this is log base 3 of 729 is 6. Log base 3 of 729 equals 6. Okay, so then the next one, if we're going to write that in exponential form, what's your standalone?
3.
The 3. We're always looking for the exponent, right? The log equals the exponent. So this 3 is the one that's all by itself over here. Then it's the log. What's your base? What's the drop down? It's the base with your exponent, right? The 2/3. So log base 2/3 of 8/27 is 3.
is the like 8/27th, is that like gonna be like a power, like up, or is that like just a number?
That's just a number, yep,
Okay.
not a power. Yeah, this is a drop down, this is a sub number, like it's lower next to your log, but that 8/27 is a number.
Gotcha.
It's a good question. Okay, so what's D? Tell your neighbor. How would you write D? Log base 7 of 1 equals 0. Okay, log base 7 of 1 equals 0. So just keep in mind, exponent, 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 right? You're always looking for it to equal the exponent. So far, so good? Okay, here's where they get fun. So like I said, you won't be able to use a calculator on this, but you won't need to for most of them. Some of them get a little bit trickier toward the end, but these first ones are pretty straightforward. Here's what you're going to do every single time, okay? If you think about it, we said we are looking for an exponent. So you're asking yourself this question every time. Are you ready? It's the same question you're going to ask yourself every single problem like this. You're going to say the base 4 to what power equals 16, right? We're looking for an exponent. So that base number, that little number, to what power equals the big number. So 4 to what power equals 16? 2. So the log base 4 of 16 is 2. So what's the question you're asking yourself for B?
What to 3 to the power equals 27?
3 to what power is equal to 27? What is that?
3.
3. So log base 3 of 27 is 3. Okay, so letter C, 5 to what power equals 5? The first power. What do you get for D? 2 to what power equals 16? So 2 times 2 times 2 times 2, right? That's 2 to the 4th power will get you 16. What do you think you get for E? Seven to what power equals a negative 49? It's not a negative. If you go way up here,
Oh, it can't be.
it can't be, right? A log of base B of a positive number is x. So if you get a log of a negative number, it does not exist. You cannot do it. You cannot take 7 to some power and get a negative 49, right? You can't multiply 7 by itself any number of times to get a negative value. So you just say does not exist. Okay, now it starts to get a little bit fancier. So if you've checked out because you're like, this is easy, I've got it, check back in because we want to make sure you know what you're doing here. The question you're asking yourself on letter F is 5 to what power equals 1/25? Negative, not 5, negative 2, right? 5 to the second power is 25, but if we take 5 to the negative second power, right? 5 to the negative second is 1 over 5 to the second, or 1 over 25, okay? So just remember this. When it goes from something to that fraction, 1 over something, it's a negative, right? That's what flips things for us. So look for that negative when the fractions are involved. Doesn't have to be every time because there are other scenarios. But most of the time when you're seeing that fraction there, look for a negative, okay? What negative power could you plug in there? Okay. Look at this one. What's the question you're asking yourself here? 49 to what power is 7? What do you have to do to 49 to get it to 7? Square root. What's the same as saying something square rooted? Taking it to what power? The 1/2 power, okay? So 49 to the 1/2 power, in other words, the square root of, right? 49 to the 1/2 power is 7. Okay, this one is a little different because there's nothing down here. And here's what you need to know. If there is no base in there, then this is a base 10. Okay, so if there's nothing written in there, it's a 10. So what's the question you're asking yourself? 10 to what power equals 100? So that is what? The second power. 10 squared is 100. Do you love this? I love this. I love this stuff. Okay, letter I. And this one should be like the easiest one, and people are always like, what the heck is that? But just think about it. You're asking yourself what question right now? 6 to what power equals 6 squared? Squared, right? 2. 6 to the second equals 6 to the second. So 6 to the second power equals 6 to the second power. Log base 3 of 1 over 81. What's going to show up? A negative, right? It flipped to that fraction form. So we're saying 3 to what power equals 1 over 81. So here's what I always tell people. Forget about the fraction. 3 to what power is 81?
4.
The 4th power. Okay? So if 3 to the 4th power is 81, then 3 to what power is 1 over 81? The negative 4th. So figure out which power you need and then make it negative, right? That's what flips it. So this is a negative 4. Because 3 to the 4th is 81. Are you ready for this one? This is the hardest one so far. Talk to the people around you and see if you can figure out what has to happen here. 9 to what power is 27? Talk to your neighbor. See if you can figure it out.
Oh, yeah.
What did you do?
I got 1.5.
Oh. How'd you do that?
Well, I actually just checked a couple times.
In your calculator. Okay.
Oh, that's going to be illegal on the test?
Yes, but I mean, it's interesting. The answer is not 1.5.
That's what the calculator
3 over what? 3 over, not 3 over 1. That'd be 3. No, 3 over 2. Okay, so take a look at this. You're saying 9 to what power equals 27? Well, 9 squared is 81. That is way too big, right? 9 to the first is 9. Not big enough. So it's got to be a number between 1 and 2. So if you think about how do I make that happen, then you think, okay, if I don't have like a whole number or a negative number, something that works immediately, then what can I break this down? Like, how can I simplify it to a smaller number first? Well, 9 is a perfect square, right? So if I take 9 to the 1/2 power, what is that? 3. Okay, can you get 3 to 27? How? By itself, how many times? 3 times, right? So 3 to the 3rd power is 27. So look at what we did. We started with a 9, we took it to the 1/2 power, and then we took it to the 3rd power. What do you do with the 1/2 and the 3? Multiply them, right? You're just going to multiply those together. 1/2 times 3 is 3/2, or 1.5, as Copper found, right? But we don't want a decimal. We want the fraction, because the decimal doesn't tell you what you're doing to it, right? The fraction says I square rooted it and then I cubed it. Does that make sense? So if you cannot find one, think, how can I take that starting number and make it smaller first? Can I cube root it? Can I square root it? What can I get to before I then cube it, square it, take it to the 4th power? Okay? See if you can figure out the next one then. It's the same idea. We're saying 8 to what power will get us 16? It's going to be a fraction. What's that fraction? So 8 squared is 64, right? 8 to the 1st is 8. So it's something between 1 and 2. But what can you do to an 8? Can you square root an 8? No. So you can't take it to the 1/2 power. Can you cube root 8? That you can, right? So if we take the cube root of 8, that's like saying 8 to the 1/3 power. What is 8 to the 1/3 power? 2. Okay? So if I take it to the 1/3 power, I get 2. I'm trying to get to 16. 2 to what power is 16?
4.
The 4th. Okay, so if I take it to the 1/3 and to the 4th, what power is that?
4/3.
4/3. Multiply those together, right? 1/3 times 4 is 4/3. So this is 4/3. Okay? My biggest piece of advice to you is to just slow down when you're doing these, because a lot of times people see this and they go, oh, 8 squared is 16. 8 squared is not 16, right? 8 times 2 is 16. So just take your time, go slow on those, make it make sense before you jump into something crazy, okay? Questions on that? Okay.